Hey all, it is Alt Bear here, and we're about to do our badge design stream. Updates for this week on the future badge. I'm gonna get a quick announcement out for others to know that we're streaming and it's time to join, and we'll see who joins us. Alright. So what I'm showing here on the display is what the packaged badge kit is going to look like. And we're going to do a little reveal of all the goodies in the kit and walk through it. Because that's what I've been busy putting together this week, is lots of these. Alright, so yes, check my audio, because more than once my mic has not been working. It looks like I'm working. Good deal. We got audio. Alright. And doesn't look like we have anyone from the badge team online yet. I'll stay connected to them in case they join. Alright, so we're getting towards the end. It's just a few weeks away from DEF CON, and we're less than 2 weeks away from our first badge distribution at the Dallas Hackers Association meeting on August 2nd. So because of that, we need to get a bunch of these kits and some fully assembled badges complete in the next couple of weeks. So this is a quick update. So what I did this year that was a little different was I went with these cool hologram bags. I saw them and just had to have them, and I love that they're clear in the front. So unlike my previous years where I've gone with more of this type of static bag material that kind of grays out the thing so you can't really see it well until you unbag it. Now it puts the PCB fully on display in the kit bag. And so yeah, we'll have a sticker that goes on the back that labels the the badge. The different kits will have the kit and the fully assembled, and we might have two different kits, one with the SMD parts soldered on and one without. So this is the what it looks like with the SMD parts soldered on. So there's 1, 2, 3, 4 SMD parts. So because some people aren't comfortable soldering that, we're going to go ahead and put together some like this. That way all they have to worry about is the through-hole components. But they are pretty big SMD parts. But yeah, we'll have the different labels. I got these cool lavender labels that I think will go nice on the holograph stuff. So it's the little touches, right? So we'll do a little reveal here, and unfortunately my hand is still not 100%. So yeah, we got the PCB here. Oh yeah, this is a break apart PCB, so you'll have to break it into the two PCBs. It breaks pretty easily on those lines. And then we have the ESP32 dev board is in its own little bag. This has been flashed with code that runs on the badge, so it should run right after being soldered. You shouldn't have to deal with putting code on it. Of course, you can recode it if you want, or modify the code. That's the whole point of that, but we wanted it to be functional right out of the bag. And then we have the cool lanyard. Let's do a close-up on the lanyard. Yeah, so it has the logo of the badge and my logo on there. And I love these little guys. These are my favorite. Past few years I've used these. Makes it to where you can make the adjust where it fits on your chest easily just by using that little plastic knob instead of having to tie a knot in the lanyard. Got our battery. And then we got a bag of bags and parts, and our sticker. So this is the cool holographic sticker that we did. So yeah, this I used art from the badge to put the sticker together, and I think it turned out pretty good. It's a 2-inch by 3-inch sticker, so it's not too big, but it still shows off the detail pretty good. And let me just see. Ah, we have one person viewing. Hi. All right, so our bag of bags. What this has, we have 2 bags inside of this one, but this one also has some parts. So this one has our header pins and the battery wire and some rubber bands that'll be needed. So not anything that's super static sensitive or anything. Then we have this bag has all of our through hole components. So this is the LEDs, the resistors, some of the capacitors, the switch, all those things that we'll have to solder on. And then this bag has the 4 surface mount components. So we have our transistor, 2 capacitors, and then this little voltage regulator. So all of that's put together in a nice kit. Obviously the ones that will have the surface mount components already attached won't have this extra small bag, and the fully assembled ones won't have these bags at all. They'll just have the badge and the battery and the lanyard. But that is how we're putting together the kits, and I think they turned out really well. A lot of this was guesswork as far as what would fit into what as far as bags inside of bags, and some people think I go a little nuts with the bags, but I think it's important to be able to keep the different parts separate when you're working on them, especially in a crazy hectic environment like the Hardware Hacking Village or the Soldering Skills Village at DEF CON. You don't want to be setting components down on a table and having them get knocked off and lose them. And I've had that happen, and it's not fun. So, but yeah, that's basically what we have as far as the kit. I think for the Indiegogo campaign, we sold like 35 fully assembled badges, and then I think it was 65 kits. So that was 100 total badges out of the 300 that we've made. So we'll make more fully assembled, and we'll make more kits for sale and for giveaway at DEF CON. But this is what the kit looks like, so I just wanted to share that. And then the code is coming well. We're still working out some bugs with the CTF part of the code, but what we flashed on these right now doesn't have that. It's just the LED and the non-CTF, non-wireless part of the code. So we'll reflash them before they go out with that CTF code once we get the bugs worked out. So yeah, I'm really excited about that. I am kind of sad that I did not have time to work out an add-on. I wanted to do either an add-on for this badge, just like a small add-on that had something to do with Back to the Future, and then I also wanted to do an add-on for the DEF CON official badge that'll be analog this year, that has the slot to add a PCB. And I just didn't have time to work on either of those. But luckily, I know one of the badge creators created a really cool flux capacitor add-on. And I hope to get one of those, because this badge does have an SAO connector to plug an add-on onto it. And actually, this is the first badge that I've made that has an SAO connector on it, believe it or not. So I'm excited to be able to plug an SAO on there, and if I can plug a flux capacitor SAO on there, that would be great. So looking forward to that one. The other add-on for like the DEF CON official, I know there's a couple that different people are doing, but the one that I'm really excited to get is the Whiskey Pirate Crew, True, and is putting together an add-on that looks amazing. I think he's calling it add-on or something like that. I forget the exact name, but that one looks truly amazing, and I can't wait to get my hands on that one. So I think that'll be my walking around DEF CON add-on. But yeah, I was hoping to build add-ons myself, just no time. Time got away from me. But luckily, this one turned out awesome. So we're happy with this, and yeah, now we're in the phase of assembly craziness. So what's going on now for those people that don't work on badges and don't know what goes into this? All of these little bags of parts I just showed, they have to be filled with all those components. They don't come that way. So yes, counting lots of components and putting them into bags and double counting and QA checking, because you don't want people to have one part missing that they can't put it together. So yeah, so that's basically where we're at. And to give you an idea, I'd love to show this off. So
can you hear me?
oh yeah, hey, how's it going? I'm just showing the live streamer crowd what a box of component bags looks like after it's been filled, and this is just one of 3 boxes I've filled with this one bag, right? Yeah, and then we got more of the little bag and lots of bags of components. So Sapien, I see you're on. I just did a little badge kit reveal for anyone that was online or maybe looking at this later as part of our badge design diaries. So yeah, you've been soldering badges. I think you said you got 5 soldered up so far? 5 are done.
I'm gonna do a couple more tonight.
Okay, I'm having trouble hearing you. Let me see. Okay, there we go. All right, I think I turned up the volume. All right, so yeah, you'll get some more tonight. That's beautiful. I may do a couple tonight as well. Yeah, tomorrow night maybe I'll get a bunch done, and then we have a soldering party on Saturday. So noon to 4, we'll be soldering up a bunch of these. And I know Rex committed. I'm not sure if anyone else is going to show for that. I know Sensei was talking about he might be able to. He was tentative. So we might have 5 of us. We might have more. It just depends. But yeah, we have to do...
Come in advance. Hoping that way, no matter what, it's not too bad.
Yeah, and even though August 2nd is the first distribution, the chance that all 35 of the assembled badges are going to be collected on that one night are probably rare. I bet a lot of the people are waiting for the Vegas badge collection. So if we don't hit the 35 number by the 2nd, I'm not too worried about it, as long as we have enough to cover the people that are actually there, that show up, that want those. So cool. So yeah, and then Indiegogo, I just sent an update out today, letting everyone know where we're at, and that people can opt in. I sent that with the tickets, but I guess people didn't notice it when they got their tickets. So sending it out today was helpful. I got another 7 people, I think, that opted in to having their name listed on the badge sponsor page. So that'll be cool, because I want to get that website updated as well. And then the code. So I mean, without giving any super secret details away, how goes the CTF part of the code? I know you were working through some bugs.
Yeah, the code's actually not too bad. It's at this point.
Yeah.
I worked through most of the bugs. I'm actually working on a Python script to be able to bulk load these.
Okay.
Because part of it is, when you flash the firmware, the other half is uploading files and stuff. To automate that.
So can't we include the files in, when it pushes the firmware? Can't you have it? I thought you could have it push files as part of that. No?
You know, I thought so too. I've killed hours on that.
All right.
So to be honest, I just found that, you know, I found a method, and it's not ideal, but it's, all what's really weird. I even installed the Arduino 1.8
Okay.
because that's supposedly when all this worked,
Mm-hmm.
and it still didn't work for me. So
Well, I've been using the Arduino CLI because their IDE software, their GUI, sucks. The 1.8 sucked, but it wasn't as bad as the new 2 point whatever. But the Arduino CLI software, the command line software, seems to work really well. Because that's how I'm flashing all the badges. That's how I was able to do 100 of those ESP boards today. I flashed 100 badge or 100 dev boards today simply by using the CLI software, and because then I don't have to recompile it every time, right? I compile it, I have the binaries there, and then all I have to do is connect up the new board and use the CLI software to upload that existing binary to the board, so I'm not recompiling every time, which takes forever.
good point. I know you wrote up some CLI stuff. Is what you're explaining included in your
Yeah.
steps?
Yeah. Let's see if we can show how we do that. I'll open up my code editor. Might take a second. And hopefully it doesn't mess up my stream. I have too many things open sometimes and the stream gets messed up. Alright. It's thinking about opening it.
Yeah, some of my bugs really are based on this inconsistently. I know that if I can get this to be consistent, it'll fix a lot of the issues I'm having.
Yeah. Alright.
Otherwise, it's pretty cool. Okay, it could be better, but I'm pretty happy with how it looks. And
Okay.
I'll probably on Saturday I'll walk you through it just so you can check it out. I think you'll like it.
Yeah, I can't wait to see it. See, if you're looking at the stream, I am sharing my screen, and this is the code directory of the repo and the README file, where I go into where to download the CLI versus the actual IDE on both Android or not Android, Linux and Windows. So yeah, the CLI is what I've been using, and then I have how to use the CLI, and I go into that. If you use it with a config file, you can change the directories it uses, because that's the other big pain in the ass about Arduino, is it wants to throw everything in this default directory that's, at least on Windows, it's hidden under like the app data somewhere, and it's a pain in the ass to get to it. And then on Linux, they hide it under like .arduino 15, and so you got to dig through to find where it's putting all the config files. So this way you have control over that, and I was going to show this is the config file that I put together for the Arduino CLI, where it has the URL for where to get the ESP32 packages. It has the data directory set as from the current code directory that we're working in, _data. Downloads go into /_staging. The user directory is dot, meaning this directory that we're sitting in, code. This way you don't have to look for where is that sketch, right? It knows the sketches are right here because it's dot. And there's some other settings here that I set, but those are the important ones. And then what you can do with that is anytime you call Arduino CLI on the command line, you would do config file Arduino CLI YAML to use that config file, right? And that would allow you to use that config file every time. But that makes for some long commands. Like I can type this. Let me see the encode. If I put that at the command line, that just does a config dump where I'm confirming, yeah, it's using the config that I gave it, because that's the config file it's calling. And so I go into detail on how to set up the CLI, although I did a shell script that does it for you. So you can have all of the step-by-step if you want to, or you can just run this shell script, and it does all the things that it needs to do. Basically, the first thing it needs to do is it needs to load the boards, the ESP boards, right? Download all the board definitions, and there's ways it has to do that. You have to first prime it by having it search for a board, and then you have that installs the index files, and then you install the board. And then after that, we update the indexes again, which will upgrade it. So this setup script, not only will it install all of this stuff, including like the library we use, the NeoPixel library, but if it's already installed, it will update it to the latest version. So you can run the setup over and over and it's idempotent. It's not going to choke because it's already installed. So that's kind of a cool way that I put that setup script together. And that setup script, if you're using Git Bash, like the Git for Windows Bash, it works on Windows. It also works on Linux. So I've used it on both because I code on both platforms. So I had to have something that worked in both environments. And then as far as once you get that all done, this is just the explanation of what the setup's doing. To compile code, like let's say I made changes to this sketch, right? And I want to recompile it. I could do it by hand using something like this, where I'm going to call the config file, I'm going to compile, give it the board FQBN, that's the fully qualified board name, the build path, the export binaries, and then the sketch name. Really long command line. So once again, I made a nice script called compile. And the CLI compile is looking for exactly one argument, which is the sketch name. And if it has either no arguments or more than one argument, it's going to throw this up saying this script requires one argument, dummy. And then all that does, once you have that, if it can't find the sketch that's the argument, it'll say it's not found. Otherwise, it's using that long command line I just told you. It echoes it to the screen, and then it uses that that argument to just put that together for you. It's a quality of life thing. It's not very complicated. Just that way I don't have to type this long thing, right? I can just type my script name and the sketch name, and it'll compile it. Now once it's compiled, because I have this export binaries here, what it's doing is it's creating a build directory that saves those binaries. The .bin files are there. So it has a bootloader and a partitions that we don't really use, but it has this, the ino.bin is the actual binary that we want to upload to our board. And so what we have next is, how do you do an upload, right? To upload, basically the long command line for that would be to specify our config file, say upload, give it the port, that's the serial port to use, the fully qualified board name, tell it what the input file is, and then have to give it this full path with the sketch, the build, the board, and the bin file, right? Very long config file. So of course I made an upload script. And an upload script basically says, this script requires two arguments. It's going to be the sketch name and the serial port. So you run the script, you give it the sketch, you give it the serial port, and then it'll check for those args again, and at the end of the script, it's running it. And basically it's using the port that we told it to use, and it's using the sketch that we told it to use, and putting everything else in place that needs to be there. So that way I can just run that very quickly to upload the sketch to the board.
That's cool.
Yeah, and then as far as like how to do serial monitor, you could do that just using the Arduino CLI as well. You tell it to monitor what port, and then the config for this, it doesn't need the whole config file because it's just a monitor. The only config that we need is baud rate, is the 115200. If it was, I think it defaults to 9600. If we were using a board that had 9600, we wouldn't need this part, but we have to add that in because these ESP32s are faster. So, but, yeah, and I can show you. So I have a brand new in the bag dev board. Cut this guy open. And where's my cable? I'll show you how quick this is. So plug this guy on here. Alright, so the first thing I usually do, just to make sure like what the COM port is, and also to make sure that it actually recognized it on connection, because testing these brand new ones, I've had a couple that have been bad out of the bag from China. So not many, but enough that I always do the board list first. So what this command does, Arduino config is calling my config file, and it's just saying board list. And it's going to list every board that it can see on the COM ports. And so in this case, it sees an unknown board, which is fine because these are probably knockoffs and they don't have the right board ID or something. And it's on COM4. So now I want to upload my binary, which is already there for the Future Badge Proto 02. So I'll just copy this command line. And I put, oops, I didn't copy it for some reason. I said copy. Thank you. I put bash in front of it because based on your environment, it may not know that a shell file is associated with bash, but in my environment, I don't actually need that. I could just do the / instead of putting bash in front of it. And then it's telling it to flash it with that binary on COM4. And what we'll see is that it's connecting to the board. It has the bin file. It usually is faster than this, but I think my system's slow because I got so much stuff going on. But you can see it's uploading the file right now. And then when it hits 100%, it does its CRC check, and it resets it. Now if we want to make sure that our code is running on there, because by default this code has a whole lot of stuff going to serial, I can just do the serial monitor for COM4. And now we can see that's the stuff that the code for my badge is dumping a serial. It shows you the touch sensing and the position that it's at in the LED code. So, and Control-C bricks us out of that. Oh, it also checks the Wi-Fi status, which right now WL no shield is the status when the Wi-Fi is disabled. It says it doesn't know about anything.
Yeah.
Yep.
Nice.
Yeah. So, and ooh, that was loud. But you can see how that took me like what, 5 minutes. It's faster when I don't have everything going. Well, it's faster than that when I don't have everything going on my machine. I was doing it in about 2 minutes. Pop one on, do the 3 steps, pop it off, next one on, and I did 100 of them today in a couple of hours. So it's a much faster way to do it. Now, with this, that binary upload is just the binary. So if you had files that you wanted to upload, we would have to get those files included in the binary. So the binary would have to have the files that you need where you need to put them. I don't know if that's possible or if it's just best to do your file thing the way you've been doing it. So, but either way, that should be much faster for you to flash it, and you're not having to open up another IDE. Like I've been using VS Code ever since GitHub's Atom was killed by Microsoft. I used to love Atom, but yeah, now I have to use VS Code because Microsoft forced me to. So, but I actually like VS Code, so it's not terrible.
That was pretty good.
Yeah,
What
and
happened
this
to
way you
Atom?
can use VS Code. Well, Atom was GitHub's IDE before Microsoft bought them. And
Oh, yeah.
when Microsoft bought them, the development on it kind of stalled. And then it just, it was losing user share to other IDEs like VS Code. And I think they just saw the writing was on the wall. Either they would have to put up money and developers to make it better and get user base back, or why do that when I'm Microsoft, I own it now, and we have our own IDE. So I think if it had continued to be as popular as it was in the beginning, it would have been worth it for them to maintain it. But it was losing popularity, so it just kind of went to the wayside. But it was a really nice editor. I liked that one. And this one, it took me a little while to get used to it, but yeah, I kind of like it now too.
Yeah, that's cool.
Yeah.
Yeah, I'd rather be using code because, yeah, the Arduino IDs, I mean, it works. I'll leave it at that.
Yeah, but I mean, with this, now I can use this IDE to edit the code and then compile it and push it, and I don't need their stupid IDE. So, yeah,
Yeah.
I was going to show you those
And
Wi-Fi codes.
Yeah, it leverages IntelliSense too, right?
Yeah.
I don't get that.
Yeah, so this is the Wi-Fi code that I added in this latest proto. So I have this constant, which is just showing all of the different Wi-Fi statuses that it could display. And it switches between them and returns that as a text, because these are like bits it sends back, and I'll return that as the same exact thing as text. So when you do a Wi-Fi status, it'll give you one of these statuses, right? And so if I want to see that as text, I had to do this to return it as text. And then what I did here was I have a little disable Wi-Fi function that just does it does a Wi-Fi disconnect just in case you were connected to something, that does a clean disconnect. And then it does the Wi-Fi off. And then I just print to the serial that it's disabled. I also do a disable Bluetooth where it does a BT stop, and I print that. And then what I have here is I call it set modem sleep, because in all the documentation I saw a lot of references to a modem sleep, but at least this iteration of the board that we're using does not have modem sleep. It has light sleep, which disables more than just the modem. It actually made, when I was testing with it, it disabled all of the external peripherals. So like the LEDs wouldn't flash or anything like that. So I made my own modem sleep by doing set modem sleep, where it disables the Wi-Fi, disables the Bluetooth. And the other thing that modem sleep did on, I guess, the newer boards, because the documentation I saw is that it set the CPU frequency down to 80 instead of the normal, which was like, I think, 240. But then I have my enable Wi-Fi would turn it back on, right? So for the enable Wi-Fi, I'll reconnect a network if it knew about one, set the Wi-Fi mode to STA, and show that it is started. And then I have my little wake modem sleep. So this is the opposite of the set modem sleep. The wake modem sleep, it will call that enable Wi-Fi, but first it sets the CPU frequency back to 240. So basically I tried to do in our code what some of the ESP boards do natively that I guess we can't do on ours because it doesn't recognize those functions. But yeah, this seems to work. And then in the setup for right now, because we don't have your code in here, I just do the set modem sleep, and that turns all the radios off and everything. That way it's not using that power if we don't need it. What I don't have built in here yet that I need to work on is on the touch sensing. Here it is, touch. Right now, the touch sensing, all it's doing is the boop, right? It prints out the values if it's touched or not touched, and if it is touched, it just turns everything on, right? And that gives it that little bright boop effect when you touch it. What I don't have in here yet that I'm going to write soon is the long touch, right? If it senses that I'm pressing and holding it for a long time, at that point, I want to put it in a mode where it's going to jump into your code. And then I thought I would turn on the two RGB LEDs that are in the title bar, in the Future Will Prevail title. I'm going to turn those red. Where right now they kind of do the color shift thing. I'm just going to turn those solid red so that the title is solid red, and that way you know it's in the CTF mode. The Wi-Fi is turned on, and I should be doing something with the Wi-Fi. Otherwise, I'm just killing my battery for nothing, and I should get it out of that mode. And that's where we can work out another long touch, like within your code, that if it senses a long touch, it'll shut everything down, jump out of your code, and jump back into the normal loop, right?
Yep. That makes sense.
Yeah. So I think it's progressing pretty nicely. I got this code almost there, and then if you have your code almost there, we just need to marry them together. But what I really, really want to do is to be able to load all of your code as an include, but I want to include it as a compiled include, right? I don't want it to just load a .h file or a .cpp file. I'm wanting it to load compiled C code. So we'll have to pre-compile your stuff, bring it in here, and then include it and see how that works if it calls it out. So that means basically your code is all going to have to sit inside of a function or have several functions that can be called from my code once it's included, right?
Yeah.
So instead of you having your own main line, you'll be a function that then I call from within my main loop.
Most of it's like that, actually.
Yeah.
Because, yeah.
That's what I figured.
I broke everything into a lot of classes, so most of it's like that.
Yeah, that's what I figured, but I just wanted to make sure you knew that. If we're going to have it called like a library that's compiled, that's how it'll have to be, and then we can just call it. And the reason I want it compiled is obvious. I don't want someone to be able to just pop in the USB cable, look at the code, and say, oh, there's the secret answer I was looking for. Yeah, not that there aren't people that can decompile that pretty easily, but it's extra work, and it would be something that you would have to go out of your way to cheat. And I don't think we're making our challenge so complex that people are going to want to go out of their way and decompile something to cheat on it. So, but yeah, it'll prevent the normal person that doesn't have those skills from cheating. Yeah, I think we're in a good place with the code, but we don't have a whole lot of time to get it done either. Because if you think about it, even though I flashed 100 boards in one day, I'm going to have to reflash all 100 boards with the new code that includes your code before those are ready to hand out to people. So I wanted to get them flashed, that way as we're soldering them up and have them plugged in, it'll at least light up the LEDs and we can do a quick test of, is this working, right? But that is not the final code, so I'll have to reflash everything again. Cool.
Yeah, no, that's good.
Yeah. Yeah, so hopefully if you use this the Arduino CLI code that'll work for you. Yeah, I have it working both on this Windows box and on my Linux laptop, and it works on both the same way, so works pretty good. And like I said, here's the Arduino CLI. There's a Windows link and there's a Linux tarball link. So Linux is a little more work to get going, but if you are running a Linux box, you probably have no problem with the tarball and getting that installed. But they do have nice installation instructions too. Cool. Well, I think that was all I had as far as updates go. Not sure if you had anything else. You still there? Oh, I might have lost you. I can't hear you. All right. Well, I think that is about it for this stream. This was a good update tonight, and hopefully next week will be our final update before we're packing everything up for DEF CON. So yeah, by next week I hope to have the code finalized and badges assembled that need to be assembled, and yeah, everything ready to go. So Sapien, you're back. Did you have any final words?
Nope.
I can hear you.
Okay, there we go.
Yeah.
It's the weirdest thing. It switched to my headset all of a sudden.
Oh. Well, I'm just glad that I checked the microphone this time to make sure it was working before I started actually streaming. I think last week I went 10 minutes in before people were like, dude, we can't hear you.
Yeah, I remember. Yeah, I remember. Well, the stream starts that way.
Yeah.
Yeah, I'm doing this again. Yeah.
Cool.
That's cool, man. I appreciate you showing the CLI thing. I'm gonna give it a shot.
Cool. All right, and I don't know if you heard, but I was just mentioning that next week will probably be the final stream of the Badge Diaries, because by next week we should have everything done and ready to be packed up for DEF CON. So we might do another one from Vegas, just as a first badge distribution stream in Vegas or something like that, just to get it on the diary, closing out the diaries, But as far as the badge design goes, I think we're just at the final end here. So next week we'll just wrap it up.
Yeah, that's cool.
Awesome.
And I do think doing that last one will be good too.
Yeah. All right. Well, for those that are watching on the stream, thank you for joining us, and I'll talk to you next week.